All right, Algebra 2, Lesson 36, using parallel and perpendicular lines. What's somewhat ironic about this and just the timing of things is that geometry is getting this almost exact same lesson today. And it starts off here in the notes. From geometry, you know that parallel lines do not intersect, and that perpendicular lines meet at right angles. When parallel and perpendicular lines are graphed on a coordinate plane, the equations of these lines do have special properties. Parallel lines have identical slopes. The only thing that's going to be different on parallel lines is that they'll have a different y-intercept. So perpendicular lines have slopes that are reciprocals of each other and have opposite signs. The easy way of saying that is that they are opposite reciprocals of each other. Several examples of that we could draw from. If I know, let's say, without giving any y-intercepts here, let's say we had some equations here and we wanted to write the perpendicular equation. Perpendicular equation to y equals 3x is negative 1/3 x. That's the reciprocal of it, meaning we're flipping the 3 and the 1 over and it's opposite sign. If we had something like y equals 2/5 x, the perpendicular slope would be negative 5/2 x. So we get the opposite sign and the reciprocal of it. Let's say I had y equals, let's say, negative, let's go with negative 1/5, right? So I'm going to get the opposite sign, so it's going to be positive. It's going to be 5/1 or 5x. So there's a few examples of opposite reciprocal slopes. So they'd be perpendicular to each other. If I multiply these things, that's what they're getting to on the last slide, is if I ever multiply the slopes of perpendicular lines, 3 times negative 1/3 is going to equal negative 1. 2/5 times negative 5/2 is going to equal negative 1. Negative 1/5 times 5 is going to equal negative 1. So the product of the slopes of perpendicular lines is always negative 1. All right, from here, let's look at some questions that we can answer, hopefully get you through this lesson. If I need to, I'd send you just the geometry video that I just got done making. So this is going to use some equations that we should be familiar with. So it's what's the equation of a line that passes through 6, negative 2 and is perpendicular to the line y equals negative 2x minus 4. So this is going to use an equation. Hopefully you're familiar with it, but it's called point slope form. So y minus y1 equals m times x minus x1, right? Perpendicular means I want the opposite reciprocal slope to negative 2. And my y1 is negative 2, my x1 is 6. So I just go about plugging those numbers into those places. So I get y minus, in this case, negative 2. I have to have both those negatives or come out wrong. The opposite reciprocal to negative 2, okay, flip it over. So I'm getting 1/2, and it's going to be positive. So 1/2 x minus, getting my x value there of 6. We're going to make those positive. We've got double negatives there. So we have y plus 2 equals 1/2 x minus 3. 1/2 times negative 6 is negative 3. 1 times 6. So 1 times negative 6 is negative 6. Negative 6 divided by 2 is negative 3. We want to subtract 2 from here, so we get y equals 1/2 x minus 5. 1/2 x minus 5, I get that answer right there. So anytime they give me a slope and a coordinate pair, I want to use that blue equation that you see up top. Okay. Number 2, it says use slopes to determine whether the lines are parallel, perpendicular, or neither. They're showing me A, B, and C, D. So I got 3/5, negative 2/7, 10/5, and D is 6/15. So without having to go to a coordinate plane and actually plot these things out, first thing it says is AB. All right, so we want to find the slope of AB. That is this equation, y1 minus y2 over x1 minus x2. All right, so AB. AB. Okay. So y1, let's do 5 minus 7. 5 minus 7 over 3 minus negative 2. Okay, 5 minus 7 is negative 2. That's going to be plus, so I get negative 2/5. So AB has a slope of 2/5. All right, now we want the slope of CD. Okay, same formula. All right, y1, so 5 minus 15 over 10 minus 6. All right, well, 5 minus 15 is negative 10. 10 minus 6 is 4. All right, let's see. So that's going to come down to negative 5 halves. So we've got negative 2/5. We've got negative 5 halves. Are these parallel? No, they're not the same slope. Are they perpendicular? A lot of people would say yes, because they see that they're reciprocal. The problem is that they're both negative. So they are not opposite reciprocals. Therefore, they're not parallel. They're not perpendicular. They are neither. And I can do all that without actually having to pull out some graph paper and check. So they both have negative slopes, so they're not going to be perpendicular. All right, number 3, we want to write an equation in slope-intercept form for the line perpendicular to y equals 4x minus 2 that passes through 3, negative 2. Again, we're going to use y minus y1 equals m times x minus x1. The more familiar you get with that equation, the better off that you're going to be. All right, so y minus, okay, we're using this equation, or using this part for this, comes out negative 2, so y minus negative 2 equals my m. So I'm going to go here for my m, the slope, and we want it to be perpendicular. Right now it's 4 over 1. The reciprocal of that is 1 over 4, and we need the opposite. So negative 1/4 x minus 3. X minus 3. All right, they're going to come out as positive. So we have y plus 2, distribute, negative 1/4 x. Negative 1 times negative 3 is positive 3/4. Okay, we need to subtract 2. But as I subtract 2, I'm subtracting it from 3/4. So I want to subtract something that has a common denominator of 4. So I'm going to multiply negative 2 over 1 by 2, giving myself negative 4 over 2, which is equivalent to negative 2. So we have y equals negative 1/4 x. We have 3/4. Oh gosh, I messed that up too, didn't I? We didn't take it quite high enough. Let's see, so that would be negative 8/4. All right, 3 minus 8 is negative 5/4. Okay. And that is this answer right here, negative 1/4 x minus 5/4. So hopefully we caught all that. If not, I'm more than happy to sit down with you and go through it a little bit slower. All right, number 4. The equations of the 4 lines given, we want to identify the perpendicular lines. So we want slopes that are perpendicular. Y equals 1. We've talked about this. What kind of line is y equals 1? Well, hopefully we understand and know that that's a horizontal line. And the only kind of line that is perpendicular with it is a vertical line. And you might notice that x equals negative 4 is vertical. Okay, so right off the bat, I know that lines 1 and 3 are perpendicular, but before I just say B is my answer, notice that D also allows for 2 and 4. So I need to look at this real closely. We have y equals 1/3 x plus 1. And the part I'm really concerned about is the 1/3. The opposite reciprocal to that is going to be 3 over 1, but opposite, so negative 3. So I want to see if line 4 has a slope of negative 3. So y plus 1 equals negative 3x minus 3. So we're going to distribute that negative 3. Y plus 1 equals negative 3x plus 9 minus 1 minus 1. And really the rest of this is really not as important, what we're seeing with the y-intercept there. Right, and we're getting plus 8. But this is the only part I really needed to see. And because it's an opposite reciprocal to 1/3, right, I know 2 and 4 are also perpendicular. So my answer is actually D and not B. D and not B. So we have two pairs of perpendicular lines. Hopefully that makes sense. All right, hopefully you're aware of y equals being horizontal and x equals being vertical. Okay, whenever y equals just a constant. Okay. All right, show that ABCD is a parallelogram. Okay, well in a parallelogram, opposite sides are parallel to each other. So we could look at the slope of these different points, and you notice through the answer key that they're looking at individual coordinates. So let's look at the coordinates. A is 0, 4. B is what looks like 5, 6. C is 6, 2. And D, if I have any room left, is 1, 0. Okay, so they have listed off here some slopes. The first one that's listed through most of these is BC, so this line right here. Now, would be easy enough to do, rather than just doing that slope form, is if I know I'm at 6 and slope is rise over run, I can look at the y value change from B to C. So from 5, let's see, we want the y value change, I'm sorry. Y value change. We're going from 6 down to 2. So that has, I'm going down 4. And the run is over 1. So from B to C has a slope of negative 4. Okay. Let's look at what else we have. Look at A to D. Okay. Let's look at the y values. 4 all the way down to 0. All right. So that has a slope of negative 4. And from 0 over to 1. So that has a slope of negative 4. So AD is parallel to BC. Okay. And we could go from A to B the same way. All right. A has a rise of 4 up to B, goes up to 6. So there's a rise of 2 from 0 to 5. Okay. Okay, that's going 2/5. Okay, let's look from D to C. D to C. All right, D starts from 0 and goes up to 2. Okay, all right, so it's got a rise of 2. And the run, well, the run goes from 1 to 6, so it's moving over 5. It also has a slope of 2/5. So opposite sides are parallel. So we're looking through here, all right, BC, right? Well, we know BC doesn't have a slope of 2/5. Right, we can look down here. We know BC doesn't have a slope of 5/2. All right, so far it looks kind of like C might be okay. Actually, no, it says AB. AB has, okay, so AB has a slope of 2/5. We can agree with that right there. It says BC has a slope of negative 4. We agree with that. Now everything's going to move around here for a second. So let's see if everything else in C is correct. It says CD is 2/5. Well, we agree with that. And AD has a slope of negative 4. So we can agree with everything on C as it stands. So C should be our answer for question 5. And you could use the slope formula y1 minus y2 over x1 minus x2 for all of that, just the way that you see them do it here. All right, number 6, write the equation line that's parallel. Okay, that's a little bit of a change of pace. Parallel questions are a lot easier because we keep the slope the same. So again, y minus y1 equals m times x minus x1. Okay, we want these coordinates right here, and we want to use that slope. Well, that slope is 1. Okay, so we have y minus, looks like negative 4, equals same slope, so just 1 times x minus negative 4. So we're going to go ahead and put pluses where we have these double negatives at. Y plus 4 equals, we're going to go ahead and distribute. 1 times x is x. 1 times 4 is 4. Subtract 4. Okay, we get y equals x for 6. Y equals x is our answer. Okay, everything else went away. All right, number 7, what's the relationship between the graphs of y equals 25x plus 2 and y equals 25x minus 7? Well, they have the same slope, so that ought to tell me something, but they do have different y-intercepts. Equations where the slope is the same, but the y-intercepts are different mean that those lines are parallel. They are parallel to each other. Okay, and that is because the y-intercepts are different, but the slope is the same. Okay, number 8, find the equation line that passes through negative 12, negative 3, and is perpendicular to the line y equals 2/3 x minus 1. So 2/3, let's find that opposite reciprocal slope, flip it. Okay, we got the reciprocal and opposite. So we're going to use negative 3/2 for our slope in our equation. Y minus y1 equals m times x minus x1. All right, we're going to use these coordinates. All right, for my x and y minus negative 3 equals negative 3/2 x minus negative 12. Okay, go ahead and put in pluses where I have double negatives. Y plus 3 equals negative 3/2 x. We're distributing the negative 3/2. Negative 3/2 times 12. Well, negative 3 times 12 is negative 36. Negative 36 divided by 2 should be negative 18. Okay, just want to double check. Negative 18. We want to subtract 3 from both sides. Y equals negative 3/2 x minus 21. Y equals negative 3/2 x minus 21 is my answer. Okay. Finally, question number 9. I think that's so we're just going to keep this to y equals negative 3x plus 6. That crosses negative 5/13. Y minus y1 equals m times x minus x1. I'm going to keep doing that over and over and over again until you kind of get into your head. All right, y minus, we're looking for the y. In this case, it's 13 equals my m. We want to be parallel there. So we're going to keep negative 3, x minus my x, which is negative 5. Okay, go ahead and put in pluses where I have double negatives. Y minus 13 equals negative 3x minus 15. Negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. Add 13 to both sides. Y equals negative 3x minus 2. Okay, and that is that. If you have any questions, email me or talk to me in class. Come and find me. We'll sit down. We'll try to figure this out if you're having problems with it. Okay, always look at your examples in the book. Make sure you're using your resources and your time wisely. All right, we're going to call it right there. You guys get to work.